Okay, so my name's Ian Archibald. I'm the executive director of DeepSense. We're based at Dalhousie's Faculty of Computer Science. You can see a bit of the pier behind me. That is the Port of Halifax's innovation group, and we work out of the pier offices. So we're directly connected with industry, and our mission is to help grow the marine economy with AI and machine learning. So I have a brief agenda of what we're going to cover here. We'll do an introduction of DeepSense. We'll talk a little bit about our methodology, how we deliver projects, the different types of projects that we work on, and some project examples. I'll keep this to about no more than 30 minutes, giving us lots of time for questions at the end. And I am also happy to answer questions about, say, generative AI and a lot of the emerging issues, DeepSeek, the state of generative AI and expected impacts. So happy to answer any questions about that after the presentation. So our DeepSense was founded by the Dean of the Faculty of Computer Science, Dr. Rao Chaplin, and Jennifer LaPlante was the founding executive director who currently works for the Ocean Supercluster. And really it was recognizing that there's a huge resource in the Faculty of Computer Science and a bit of not a disconnect, but opportunities to connect the faculty with industry. The marine sector is, of course, one of the top industries in Atlantic Canada, and it's really something that as a region we specialize in. About half of the startups, marine technology startups in Canada, are based here in Atlantic Canada. We have huge resources in Dalhousie University and the Ocean Frontier Institute, Department of Oceanography, Tracking Network. We have COVE, which is, of course, a significant partner of ours and very much a significant resource, especially for defense or hard tech in the marine space. We have extensive biosciences at Dalhousie. We have the Medford Institution of Oceanography, and it just, with so much activity, and we're also the home of the Atlantic Fleet for the Canadian Navy. So with so much activity here, it was how do we connect the resources and expertise of the Faculty of Computer Science with the marine sector in Atlantic Canada and across Canada. So, just that question of should these technologies, specifically machine learning, AI in general, and now generative AI, shouldn't there be a way for the Faculty of Computer Science at Dalhousie to deliver these technologies to industry? And that was really the motivation for the founding of DeepSense. We work across a wide variety of sectors in the marine sector: energy, transportation, logistics. We do work in transit, recreation, tourism. We've had quite a few projects in fisheries and aquaculture. We're very excited to get into more military and defense contracts. We're actively talking to DRDC, the Canadian Navy, and very excited about the NATO Diana initiative that COVE is leading, and we're looking forward to taking part in that as it matures. We do some work around biological and physical oceanography, and quite a bit of work with autonomous systems. So essentially enabling marine drones to do their job, whether that is fully autonomous or guided. So artificial intelligence is arguably the most important general purpose technology in decades. General purpose technology is a technology that will find its way into all of our lives, both personal and professional, and really change the way we live and operate. Examples of general purpose technologies are, say, electricity, information technology, fire, the wheel. These are foundational technologies whose adoption fundamentally changed the way we operate. And I think it's important to note that artificial intelligence is a little bit different than many of these in the time that it is taking to be deployed. Machine learning as a as a discipline or sort of subsector is now a few decades old. And of course, we're seeing generative AI, another type of artificial intelligence, explode onto our awareness. And it's wildly powerful and evolving at a very fast rate. So, how can we help the marine sector leverage these tools? We really do four core activities here at DeepSense. The first one is we work with established companies to deliver machine learning readiness projects, machine learning ops or audits. That's where we work with more mature machine learning mature organizations that say have multiple machine learning models, and we help them understand data flow, model integrity, recommending more efficient models. Machine learning readiness is about helping organizations set up data collection, data labeling, different structures to leverage machine learning and AI in the future. And then we actually do machine learning and AI projects where we train specific models for organizations. We're starting to get more into generative AI projects as well, where we leverage those technologies to help First Nations, to help individual businesses. So really kind of the wide range from companies that are just looking and trying to understand how they can potentially leverage AI and machine learning through to companies that have been using these technologies for a long time and want a sort of second look at their operations and machine learning structures. And that's something that we can really provide at DeepSense because we are part of the Faculty of Computer Science. We do have PhD students on staff who specialize in AI and machine learning and are able to really deliver cutting edge advice using the latest or recommending the latest best practices in AI and machine learning. The second group that we work extensively with are startups. We are a mentor and do projects with the Ocean Startup Project. Again, we're looking to do projects with the NATO Diana companies when they come online, and we again offer a number of different services to startups. The first is just strategy and consultation. I myself was a startup founder from 2014, sold the business in 2020. We had a machine learning first startup building modern management tools for marine facilities, sort of optimizing boat placement and scheduling, among other things. So can actually advise startups on how to develop their strategies to leverage these technologies. We do a lot of building AI and machine learning models for startups, and these are often at the core of their value proposition. If you talk about most of the top startups that have been founded in the past 6 years in the marine space in Canada, large number of them are running models that we developed. And we also can help them with operational capacity around machine learning and AI. Of course, with both of these, a perfect situation is we engage with the company, we do a project with them, and then they hire the student who did the project moving forward. So our goal here at DeepSense is not just to sort of provide these services and expertise to startups and more mature organizations, but to actually be a talent pipeline where these organizations essentially get a 4-month interview with the student. They get to work with the student directly, see what they can do. The student then builds under our guidance, builds whatever system it is or provides whatever value. And the business or startup can hire the student to continue the work into the future. And that's an optimal outcome for us. So not just sort of providing the expertise, but actually building real capacity. And that leads us to the third thing that we do, which is really introducing these next generation of machine learning and AI experts, our students, to the marine sector as a viable career path. Most of the students who do our projects come from Dalhousie's Masters of Applied Computer Science program. This is very much applied research. So these students are trained in real world methodologies and deploying how to deploy these models and technologies in business, in organizations. And we do quite a few of events, work very closely with, say, Shift Key Labs and the Faculty of Computer Science. That's their sort of professional development organization or sort of group in the Faculty of Computer Science. And we work very closely with them so that we expose the general student body to the marine sector with the hope that they'll look for careers in amongst our companies in our region. And then lastly, we collaborate and support partners to bring AI and machine learning capacity into their operations. And we can do this through education. We often do education sessions with our partners just to update them on the technologies, including some of the latest developments in generative AI. We say partner with the Ocean Frontier Institute on their seed fund. So we do machine learning projects with some of their researchers that receive their seed fund. We work very closely with Cove on a number of projects, including a really exciting one right now of working to develop a prototype to surveil marine protected areas for the Department of Fisheries and Oceans. It's a lot of fun, and we're going to use satellite imagery and AIS data and all kinds of great stuff to develop a prototype so we know what's happening in our marine protected areas. We work closely with, say, the Marine Institute at Memorial University to increase their machine learning and AI capabilities. We have a number of projects starting with them shortly. And yeah, just sort of generally help the ecosystem understand what these technologies are and how to leverage them. So yeah, quite a few information and training sessions with various organizations in the region. And we are expanding outside of the region. We're building partnerships with Coast out on the West Coast. We're working closely with a number of companies in Quebec's Rimouski Ocean Technology Hub and are really excited to expand more across Canada and service as many companies, organizations, startups as we can who are in the marine sector and are interested in these technologies. So how do we do this? First is we work with companies and startups and organizations to understand problems that need solving. So we generally are approached by organizations and say, hey, we've got to leverage this technology. How are we going to do it? And we work to define a problem statement. Essentially, what are they looking to accomplish? And then from there, we create a partnership. So we create a partnership based on, some of these are very informal partnerships. Whenever, of course, there's IP involved, we're doing actually machine learning or AI work, then we require a more formal partnership that allows us to make sure there's no questions or issues around IP. And then we scope out the project. So we're very proud of our track record of delivering our projects in scope and on time. And that's because of the work that our project managers do. They've now seen dozens of these projects. So we work really hard to make sure that everything's properly scoped out and we can deliver within people's expectations. Then we do the work. Usually, again, a max student, but we can pull everything from PhD level students if that's what the project requires. And we have done projects with undergrad and even NSCC CTAC students, depending on the nature of the project and what's to be delivered. So then, of course, after the proof of concept, prototype, machine learning audit, machine learning readiness project is delivered, we hand back all data or delete the data if requested. We hold no IP in anything that we do. It's a core part of our offerings. We're very much an enabling service-based business. We're here to help support and serve the organizations that we work with. And yeah, in a perfect situation, we want to see what we do commercialized and deployed at scale in our economy. So again, we hold no IP. We have no interest in holding IP, and we are not a data warehouse. Generally, our partners bring us their own proprietary data. Then we use that proprietary data to train proprietary systems that are handed back at full ownership residing in the company or organization that we work with. So how are our projects structured? You have your project partner, whether that's a small, medium-sized organization, academic institution, researchers, what have you. And our program managers are key. They manage all of our projects from initial introduction right through to closure. They meet with the student and the company once a week, the student one-on-one once a week, and then leverage the rest of the resources, whether that is our data and algorithm leads who are active PhD students at Dalhousie. We have a cloud architect and cloud engineer on staff who help with the infrastructure for our projects. We try to build the projects on whatever infrastructure our partners use. So we are AWS first, but we can also do projects on Azure or Google Cloud. We're actually developing a proprietary platform right now that will make these projects easier to deliver. And then we can pull in faculty and other data technicians as needed. If there are deep questions that are not easily answered by our machine learning experts, we can pull in specific expertise across Dal's faculty to consult on different projects. So it's not just a sort of machine learning or AI focused. We can pull in expertise from the Department of Oceanography, linguistics, sort of basic consultation across Dalhousie, which is an incredible resource and something that, like any project, we do get stuck. But we've got the resources to find the answers when we do. And it's a huge strength of our organization. So, little bit of a hero slide here. We were established in 2018. We have now delivered over 75 machine learning and AI projects. We're currently at a run rate of about 25 projects per year, so we're actively scaling as an organization. Our goal in the next 2 or 3 years is to potentially hit up to 60 projects per year. We've worked with over 50 project partners. These are predominantly industry partners, so small, medium-sized businesses and startups. And it's important to note too, we do have some long-term, more mature partners like Innovacy. They use us often for skunk works. The question, a more mature business wondering if developing a certain value proposition or product offering is possible. And then we work with them to do that innovation work, hand it back, and then they can productize and commercialize what we develop. So an example of that would be we worked with Innovacy to develop a system that can predict oxygen levels in aquaculture pens 48 hours in advance. One of the biggest issues in aquaculture, especially sort of fish aquaculture, is you have algae blooms that suck all the oxygen out of the water, and then you get fish die-offs. Of course, if you can predict if that's going to happen, you can either aerate the pens or remove the fish from the environment and save huge costs and a huge environmental hit in the process. So we helped them develop the model. They then took it back in-house with their own machine learning expertise, extended it to 72 hours in advance, and they are now they've commercialized it and are actively selling the service to monitor oxygen levels in aquaculture pens. So that's sort of one example of how we help our partners figure out value propositions. And Innovasi is really a founding partner in many ways of DeepSense with ongoing projects, and they often hire the students who do their projects to continue their work at Innovasi. We've delivered over 60 internships with our partners, with our students at the core of them. We have about a 95% success rate of our projects, and we've either delivered or been part of organizing over 200 events that introduce our student body to AI and to the marine sector. So big part of what we do, again, is that talent pipeline into the ecosystem of students who have machine learning and AI expertise. Any questions on what we've talked about here? It is sort of yeah, Sydney, anything in particular?
No, we're all good so far.
Cool. Okay, get into the projects. So a lot of the machine learning projects that we do is about finding efficiencies. Examples would be, we can play with all kinds of different data, structured data. We do a lot of visual, sort of machine vision projects, a lot of work with underwater cameras. And a lot of what we're looking for with machine learning, like there's sort of three types of AI. There's deep learning, machine learning, and generative AI. We mostly focus on machine learning. We're starting to get more into generative AI as the technology explodes onto our economy and society. But most of what we do right now is machine learning projects. So with machine learning, what you're doing is you start with data, and then you have a machine learning model that you're training with the data, and then using subject matter expertise to essentially shape the outcomes to get a repeatable value. Whether that's identifying something, whether that's sorting things, whether it's creating a repeatable value that you can deploy in just about any setting. That's a lot of what. So if you can imagine, social media feeds are often based on machine learning. The way our traffic lights work is based on machine learning. You're sort of looking for patterns and then looking for repeatable value in those patterns. Schedule optimization, and we'll get into sort of some of the specific computer vision stuff in a minute because it's really fun. So we also do work with text data. We do a lot of work with sensor data and getting more and more into acoustic data. So natural language processing, being able to read massive amounts of documents and pull information out of it. We can do a lot of redundancy work. So something that we've done more than once is if you have, say, two weather buoys and developing a model so that if one of those weather buoys goes down, you can predict what the sea state would be at the other buoy. So great at just redundancy and making sure that if one part of a system fails, that the whole system doesn't collapse. And many times you can actually extrapolate what that part of the system would be doing from the data captured from other parts of the system. So very, very powerful technology, and really at the core of much of our modern lives. So this is a fun little exercise here. This is a project we did a few years ago around recognizing whales from satellite imagery, very much connected to the current Cove project that we're working on around marine protected areas. And there is actually a whale in this picture. Now you're probably thinking, well, of course it's the thing in the middle, and that's actually a boat. So there's a whale in the picture here that is not in the middle, and that whale is right there. Can't tell with the human eye, but these systems are able to pick up patterns that we often can't recognize. And how they do that is we take thousands and thousands of images with whales, I think minimum 1,000, to do sort of a rudimentary machine learning, but oftentimes many thousands of images where whales have been identified by people. And then we train these systems on the data and then bring in expertise to help shape the outcomes that we're looking for. Another example is we work closely with Glass Ocean. They're another sort of founding partner of ours in many ways, literally right next to us here at the pier. They develop hybrid electric systems for inshore fishing boats. And we've been working with them for a long time to do all kinds of things like load management, predicting load management between the gas and electric systems, predicting how long, say, battery life is in these systems, and a number of other performance based projects. So we love working with them, and we've really sort of had a lot of fun seeing them grow and develop with the technologies that we've helped them develop. There's another fun one. This is a project where we're looking at bivalves, so mussels, clams, oysters, and basically a canary in the coal mine scenario. We're tracking how much they're open as an indicator of water quality. So you can see this is what a machine vision model looks like in work, and all it's doing is tracking how open and closed these different creatures are. So you can see them starting to close in various sections, and that'll give us an indicator to water quality. Another really cool machine vision project that we've done is on deck fisheries. So you can see there's a machine vision model that's actually tracking and identifying fish as they're landed on the boat. So the ability to understand what bycatch, understanding what people are pulling in, we can even size different creatures as they're being harvested. Again, we do a lot of work with numerical data. In this case, we've got shipping logistics. So basically taking all these old manifests and analyzing the data. And we're actually looking to get into a lot more projects like this with the port of Halifax. And, you know, incredibly powerful what we can do as far as helping with scheduling, building more redundancy into their systems, and generally helping a complex operation like the port get more efficient and effective in what they do. So that is our overview of what DeepSense does at its core, the kind of projects that we deliver, and the kind of things we do.